Hi, we're the alkaline earth metals, and today we'll be making pancakes. For our pancakes, we have a few ingredients. We have 1 cup of wheat, or flour. We have 1 cup of milk, 1 egg, 2 tablespoons of sugar, 2 teaspoons of baking powder, half a teaspoon of salt, and 2 tablespoons of butter. So first we're going to add all our dry ingredients to one bowl. So we'll add the salt, the flour, and the sugar. We also add baking powder to that. We mix all the dry ingredients together.
Next, we beat the egg.
Now we add the wet ingredients together. We've already added the egg and the milk, so all we have to do is add the melted butter.
All of these ingredients require refrigeration. Take milk, for example. If milk is left out for too long, it will spoil. This means that the fat and protein have separated and the protein-rich whey becomes sour. Butter, on the other hand, is not as high of a risk to be left out. At room temperature, it will become overly soft, but as long as it is eaten quickly, it may be left out for a few days. Lastly, an egg is recommended to live in the fridge. This is due to the fact that although there is an outer coat to protect the egg and keep it from spoiling too quickly, being left at room temperature increases the chance of bacteria growth. Although rare, it is possible for the yolk inside to become infected with illness such as salmonella during production. Refrigeration prevents the bacteria from spreading throughout the rest of the egg, reducing the consumer's risk of infection.
Next, we add the wet ingredients to the dry ingredients.
Stop that! Let's talk about baking soda. If you've ever baked a cake, made cookies, or pancakes in our case, you've probably come across an ingredient called baking soda. Like most others, you probably haven't given much thought as to why bakers use it so often. Well, here's why. Baking soda, not to be confused with baking powder, is sodium bicarbonate, NaHCO3. This sodium bicarbonate is added to baked goods to make them rise. Recipes that use baking soda as a leavening agent also contain an acidic ingredient, such as lemon juice, milk, honey, or brown sugar. Our recipe calls for baking powder. Unlike baking soda, the baking powder reacts twice. Once when we mix the liquids with the baking powder and other dry ingredients, and then again when we cook the pancakes. In the first reaction, when the baking powder is mixed with a water-based liquid, the baking powder releases a small amount of carbon dioxide. In the second reaction, when the pancakes are being cooked, because of the heat, the baking powder releases a lot more carbon dioxide. This carbon dioxide is released inside of the pancakes and causes little air bubbles to form. The bubbles lighten the batter and also push the batter away, making it less dense, which makes the pancakes rise and become fluffier.
To cook these pancakes, we will be using cast iron. Cast iron has a high specific heat capacity, so it takes longer to heat up, but once it heats up, it holds a higher amount of heat, and it holds it for longer. So we got the cast iron heating pretty quickly, so that we wouldn't have to wait on it. Also, the way the pancakes heat up is an example of conductive heat energy, because the fire is heating the cast iron, which then in turn heats the pancakes. That's conductive heat energy. We add butter to the pan to keep the pancakes from sticking to it. And you can see that there's conductive heat transfer because the fire is directly heating up the pan, which then in turn melts the butter. This will happen for our pancakes too. And now that the pan is now buttered up, we can begin cooking.
Cook the pancakes.
Now we're just going to have to wait for it to cook. First one's always the worst. We didn't take enough time to have the cast iron pan heat up. I underestimated how long it takes for it to heat up. So we might just have to wait a little bit. But isn't there some sort of reaction going on while these cook, Kyle?
Yes, on the underside, the Maillard reaction is happening. Don't those smell good? Underneath the pancake, the Maillard reaction is happening. Come closer. Once they're ready to flip.
Which isn't yet. Or maybe it is.
You see the browning on here? This is caused by the Maillard reaction. The browning and aroma of the pancakes is caused by the Maillard reaction. The Maillard reaction is named after the French chemist Louis Camille Maillard. The Maillard reaction occurs when the sugars react with the amino acids inside the pancake batter. This only happens during the cooking of the pancakes because these types of chemical reactions are thermogenic. When heat is added to the pancake batter, the carbohydrates within its cells start to break down. After this happens, the carbonyl group, carbon atoms that are double bonded to oxygen atoms, start binding with the amino groups of the amino acids. The Maillard reaction also occurs in the human body. It is a step in the formation of advanced glycation end products, or AEGs. An AEG is the result of chemical reactions inside the body. Excessive consumption of carbohydrates cause AEGs to form beyond normal levels. This can lead to diabetes, Alzheimer's. The Maillard reaction can also be achieved at lower temperatures by increasing the pH of the item being cooked.
And now you know the chemistry of pancakes!
Those look good. Thank you for watching.